Hello everyone and welcome to this video for PROG1198. During this video we're going to be modifying our UWP client application in order to make use of our stored procedures in our database. So we've studied stored procedures in the past and we discussed writing some standard stored procedures around tables so that we can encapsulate the main functionality of database table access. So we wrote stored procedures for retrieving one element, retrieving a list of elements, and performing insert, update, and delete queries. Now, our goals of implementing stored procedures in our UWP application are to decouple the SQL logic from the data layer. So our current implementation has our data layer class, which contains SQL statements. And rather than have that tight coupling between, if our database table changes, we have to come and change our data layer, we want to separate the two so that the data layer doesn't need to know about the underlying structure of our database objects, such as the tables or views. So we do that to protect our tables and views and also to protect our data that is stored inside of them. We also want to keep that separation between the responsibilities of the database versus the responsibilities of the library. So if we take a quick look at the code in our library class, and this is the solution that we finished in the last video, you'll see how there is SQL code written right into the library. So our goal is to remove the SQL code and replace it with calls to those standard stored procedures. So of course, if we're going to call stored procedures, we have to make sure that those procedures exist in our database. So the first step of this would be to write those 5 standard stored procedures for every table that we need for our CRUD operations. So that would be select all, select by primary key, insert, update, and delete. Our application has been working with departments, so I'm going to write these 5 standard stored procedures based around the department table so that we can have this procedure for a way to retrieve all departments, retrieve one department given a department code, and then insert new department, update, and delete. I'm not going to demonstrate them all because this is a topic that we've already covered before, but I'll do a few of them that we need for this demonstration. Once we've got a set of standard stored procedures around each table that we're interacting with, we also might want to consider writing some additional procedures. So some of them that we're going to look at are, the first one is writing an ordered list procedure. And we can use this for populating a combo box. And then the second one that we're going to look at is writing a dynamic filtering procedure. So it's a stored procedure that will return records that match given input parameters. But we're going to start with the standard stored procedures. So the first example that we'll do is we want to write a stored procedure that selects a given department from its primary key or department code value. This is going to replace the SQL statement that runs our get department by department code method in our library. So rather than writing this statement, we're going to call a procedure. So I'm going to open up SQL Server, and we're going to write a stored procedure that allows us to select the department records based on the department code. I'm also going to follow all of the regular stored procedure rules and best practices. So that is, we want to turn no count on because it's a select procedure. We want to list all of the names of the fields rather than just doing select all. So we want to continue to follow those good practices that we learned about when we studied stored procedures. So we start out by creating the procedure. And we give it a name. I'm just going to pause the video while I type the rest. So here's our completed stored procedure. It takes in one input parameter, the department code. It doesn't count the rows affected because we know that there will be no rows affected by this procedure. And then we select all of the fields from the department table where that code matches. Note the department code is required. You can't call this procedure without passing a department code. That's going to be something important to remember later when we try to call this procedure from our application. Okay, so in order to create the procedure in the database, I'm just going to execute the create statement, and we will also test it out by writing a little exec statement. So we'll provide a value for department code and make sure that we can retrieve one department record. So now that the procedure exists, we can move on to the next step, which is modifying our getDepartmentByDeptCode library method so that we call a stored procedure instead of directly coding SQL. So you can do it in the other order. You can modify your method first and then go back and write the procedure later. But just keep in mind that if you call this method and it tries to execute the procedure doesn't exist, obviously that's going to give you an error. So here's how we modify the getDepartmentByDeptCode method. You can see that we still have the same 3 lines of code. I'll just switch over into here for a minute. So we define the SQL that we want to execute, and then that gets passed to the query method, and then we return the resulting department object. So there's only 2 changes that we need to make in order for this to work as a stored procedure instead of as a SQL statement. And the first is we replace the SQL statement with the name of the procedure. Now, in order to preserve our work that we've done before, I'm just going to comment it out instead of changing it. So we put in the name of the stored procedure here. I'm going to copy it and paste it. That's a great way to avoid typos. So we define our SQL statement as just the name of the procedure. No exec statement, no parameters, just the name of the procedure. The parameters have to remain here. So if we have an input parameter that is required by the stored procedure, then we need to pass that down here. We're still just retrieving one record, so I'm going to leave single or default there. But there is one more change that we need to make. We need to specify that this thing is not a plain text command, that it is the name of a procedure. So the way that we can do that is by adding another parameter to our query method call that indicates the command type. So again, I'm just going to comment it out so that we have the older version to refer to later. I copied and pasted. So after the query text and after the parameters, we put in a comma so that we can add another parameter that specifies command type. So command type, colon, and this is an enumerated type, a list of different types of commands. So we want command type dot stored procedure. So text is the default, but we want to switch to stored procedure. I'm just going to maximize this so we can see everything. So we add in this command type parameter. Watch the lowercase c here and then uppercase c there. We know that C# is case sensitive, so if you're getting underlines, check that. And that's all there is to it. Those are the only changes that are required in order to switch over from using a SQL statement to executing a stored procedure. We give the name of the procedure, and then we change the command type to say, hey, this thing's a stored procedure. It changes how it executes, but none of the other logic needs to change. So we're still retrieving one single department and returning that object. Now, that was a pretty straightforward example. So I'm going to move on to one that is a little bit more complex, which is performing an insert. So the insert stored procedure needs to provide more than one input parameter. Now, because the department table is a little bit unique in that it doesn't have an integer identity as the primary key, the insert procedure for departments deviates as well from the recipe that we usually use. So for inserting departments, because the user provides values for all three, we need to take input parameters for department code, department name, and department budget. Most insert procedures would contain an output parameter that is set to the value of the new record's identity. So for example, if we were inserting customers, we wouldn't be able to specify what value we want for customer ID, or excuse me, for employee ID if we were inserting employees. We can't provide a value for that because it's an identity column and it's generated by the table when the insert happens. So typically what we would do for an insert procedure when the ID is an identity is we would have that output parameter. We would select the value of the recent identity and return that after the fact. So I am going to show you that example just because it differs from the department one, but I do also want to do the department example so that we can continue making our department app. So we'll take a minor tangent a little bit later to look at that insert with an identity primary key, because I know that will help you manage that on your Lab 5, and it's an important skill in general. So let's do department inserts first. Again, I'll pause the video while I create the procedure in SQL Server. So here it is, our procedure that takes those three input parameters for the three columns in the department table. We have a default value of 0 for budget because budget is an optional field that allows null values. We can also choose to assign it null, but I've chosen the default of 0 here just to keep it numeric. So we set no count off. We do want the number of rows affected to be counted, and then we perform the insert. So again, I'm going to execute this little bit of code so that we can create the procedure. And if we want, we can also write an exec statement to test it out, make sure that it works. So I'm going to make up a new department with a name and a budget here. And we can try to execute that. So we got the one row affected message, and I'll select from our department to make sure that the insert worked, and you can see there's our new department right in there. So once our procedure has been created, then we can go and call it from our library method. So I'm just going to modify the insert department code library method. Let's go back to our code here. We can find insert department. And you can see that we're going to have the same thing happen where we have an SQL statement, and we don't want SQL code in our C# code. So instead, I'm going to put in the name of that stored procedure, USP_insert department. So that is step 1 of using stored procedures. Step 2 is changing the command type. So we do the same thing here, where we're going to add that third parameter for command type to change it to a stored procedure. So that's all, and it's pretty straightforward. And part of the reason why these were both so straightforward is because in both cases we're just pushing a query without using anything like output parameters. So I'm going to take a minor detour now, and we're going to look at performing an insert that allows us to retrieve something. So when we passed the department object, that's how we were able to provide values for all of the input parameters required by the stored procedure. So the department one worked so easily because this piece here, the department object that is passed in, contains values for all three of those input parameters. A department object has properties for depth code, depth name, and depth budget. And because the properties have the exact same names, and because all of the properties contain a value, passing this object to execute allows them to map or match up to the parameters that are required by this stored procedure. It's not always that simple, though. The only reason why it works are because it checks all of these three boxes, that all of the department object properties already contain values, that all the property names are exactly the same as the parameters required by the stored procedure, and that none of the stored procedure parameters are marked as output. So we're taking one department object and pushing it right into our department table. But if all of the above conditions can't be met, then we have to manually create and pass the parameters to the query or the execute method. So what that means is if we have any anomalies or differences in the types or the values or the names of the parameters, then we have to do a little bit of extra work rather than just simply passing a matching object. So to demonstrate this, we're going to look at inserting an employee. So here's a typical procedure that we would use to insert an employee record. We have input parameters for all of the employee columns except for employee ID. When we want to create a new employee, we don't know what the employee ID is going to be yet. So we can't pass in an input parameter saying, hey, this employee is going to be employee number 23. We don't know what the number is going to be, so we can't provide it. However, insert procedures usually return the generated primary key value as an output parameter. And that's actually going to really work to our advantage when we want to create a new employee through our app, because when we create a new employee through our app and we insert it into the database table, we can get that value returned and we can set the employee ID property so that our employee object in our app then will get and know its new ID value. So we want to be able to pass data both ways. Now the logic of the procedure is very similar. We set no count to off. We perform the insert statement with all of the other input parameters. And then we have a select statement that returns and assigns the value of that output parameter. So we have two goals now. We need to pass in the employee values, but we also need to capture and use the output parameter. And this procedure falls more in line with what a typical table would be like, because most tables have that identity primary key. So I'm going to pause the video while I put this procedure into my SQL Server, and then we'll move on. So I've typed my procedure here. I'm just going to execute it to make sure that it is stored as a database object. And we can also execute it to insert a new employee. And I'm going to provide values for all of these input parameters. Now notice that some of them have defaults, so I could leave some of them out if I wanted to, but I want to test all my parameters, so I am going to provide values. The other thing we have to remember is that we've got an output parameter coming, so I need to declare a place for that to be stored after executing. Now this is just for testing purposes. I want to make sure that my procedure works correctly. This isn't part of making it work for the app. I'm just testing my work to make sure that it's, if I do have a problem in the future when I try to run the app and it doesn't insert, there's so many working parts. We have the user interface, we have the data library, now we have the stored procedure. I want to eliminate the stored procedure as a source of future problems. So I'm going to test it now, make sure it works perfectly. That way, later if I encounter a problem, I can say to myself, well, no, it's not the stored procedure. Okay, so I'll pause the video while I type the rest of this, and then we will make sure that this procedure works correctly before moving on. Okay, so I've written an exec statement along with a place to store that exec statement result. We're providing values for all of the input parameters. And then the output parameter, employee ID, is going to be stored here in this local variable called new ID. And then I'm going to select it as new. Okay, now before we start, I'm going to take a look at what's currently in employee. So we can see that these records, there's 8 employees here. Just move this up a tiny bit more. And when I execute the insert statement, the newly generated ID is 9. And if we look now at what employees we have, here's our new record with its ID. So our stored procedure is done. It works. We tested it. We can move on. Now, this is a bit much, I know, but we'll take it bit by bit. When we want to perform an insert, and we want to be able to retrieve as an output parameter a value, or when our object, in this case it's an employee type of object, doesn't contain all of the things that we need for the input parameters, or if our object properties have different names from the input parameters, any kind of deviation from the basics, what we learned in the insert department one. If anything's different, then you need to handle the parameters manually instead of just passing in a matching object. So let's deconstruct this example a little bit. The first thing is defining the SQL as calling that stored procedure. That part is the same. But next, we create an object called a dynamic parameters bag. Now, bag is kind of like a list, except there's no order to it. This particular data type, you can treat it like a list. Notice that you can call an add method. And what you add is like a parameter type of object where you specify the name and then you specify the value. The value comes from the new employee object's properties. So most of the values line up, right? But we know that the employee ID is going to work in a different direction, and this is where we can also deal with differences in data types. So for example, if we take a look at what we created for our employee object class, and we haven't looked at these object classes in a while, but you might remember from a previous video creating these objects, and we try to match the data types as closely as possible. But there are some minor differences. For example, emp start. In the database, emp start is a date data type without the time. But we don't have an exact match for that in C#, so we use date time. But if we try to provide a time piece to the database, like if we have a start date as January 1st, 2020 at 10 a.m., then the database is going to reject that, right? Because it's only set up to store a date and not a time. So this is another example of the parameters not exactly matching what the database is expecting. So in here, creating a bag of parameters allows us to control the names and their attachment to the values. So for example, if your employee object had a property called first name instead of emp first, then this is where you would match them up. You would say the database parameter at emp first would match up with new emp dot first name. So that's how you can customize the name of your parameters. Also with our emp start, we provide the start value, but we can add a third parameter indicating the type that we want to pass to the database. So DB type is a collection of types that refer to types that are found in SQL Server databases. And the final change that we made in this last parameter, emp ID, you still have to provide some kind of location for the value. because it doesn't allow you to pass null. But you'll notice the third option here is a direction indicator, indicating that this parameter is an output. Now, if you don't specify, it thinks it's an input parameter. The vast majority of our parameters are input parameters. But this one is an output parameter, so we need to indicate that by saying that the direction is output. Now, we had a statement that executes that given SQL, and one change that we make here, let me just highlight it, is that in the department example, we pass the department object. But now, because we wanted to make changes, we don't pass the employee object, we pass the parameter bag instead. This allows us to customize the mapping. If we just pass the employee object, then we wouldn't be able to make these kinds of changes. So we pass the list of parameters, and we have to make sure that we set it to stored procedure. The stored procedure will execute, and after it executes, we can call from the parameter bag a get method that allows us to retrieve the value of that output parameter. So what do we want to do with that value? We want to assign it into the employee object. The employee object didn't have an employee ID assigned before, and after the stored procedure, we can get the output parameter and assign it to the object. So that employee would then know what its assigned employee ID is. So let's put this into our code library. So I'm writing a method now that will allow us to insert employees. It's based on inserting departments. So I'm going to start by copying this, and I'm just going to paste a copy down below, but we're going to modify this one so that it works to insert employees instead. Now I could pause, but I want you to see how I'm modifying it. Everywhere we refer to a department, we're going to refer to an employee. Oops. Come on. There we go. And I'm even going to change the name from new dept to new emp. So here, and there, and there. Now, the SQL statement is going to be called insert employee. I'm going to just remove this old comment that we don't need. And you can see how the template says we'll pass the employee object. But we know now that the employee object isn't a perfect match, and we don't know what the employee ID is going to be. So we can't pass the employee object here. I'm just going to use that placeholder for a minute before I make the parameters. So we create an object, dynamic parameters. And I am going to pause the video while I type the rest. So we have to remember to create a parameter for all of the parameters in the stored procedure. We have to remember to change date-time objects to a database date type. Now, if your database uses date-time or date-time2 or date-time offset or any of those, then it will translate no problem. It's only when you have to actually make changes. So most of them map really well. Like if you have a double or a decimal, then you can put that into a decimal in the database. If you have a string, then you can put it into a char or a varchar or an nvarchar or any of those other string database types. So here's our list of parameters, and we use our list of parameters to map these database parameter names to the values that we want to send that come from the new employee object. We can contrast that with the previous one where we passed a new department object and just sent the object right to the execute method because it mapped perfectly. This one doesn't map perfectly, so we have to do a bit of extra work. Now, after this is executed, Then we can retrieve the value for the new employee ID, because this new employee object wouldn't have an employee ID until after we put it in the database table. So I'm going to set the new employee emp ID to the value that we retrieved from the output parameter. So we call a get method. We specify the data type of the thing that we're getting, int in this case, because emp ID was a data type of int, and we specify where we're getting it from. So now when we return the employee, it's the same employee that we passed in, except now it has a valid value for emp ID, because the stored procedure generated it and returned it to us, and we assigned it into our property. Now, the front face of our app, we're going to move over now to looking a bit at the user interface. We have an interface that allows us to find one department, to display a list of all the departments, to delete, to add, and to update. But this page doesn't allow us anything to do with employees. So the first two methods that we changed today, the getting department by department code and the inserting department, we don't have to make any changes to how our user interface project works. If I look at the code behind of this, all we're doing in all of those cases is calling those methods. So we have a very nice decoupling here where changing the methods doesn't change how the user interface calls them. So even though I made those changes to go over to stored procedures, we don't have any difference in changing this. So I'm still calling the same method, just how the method works got changed, but we don't need to know that over here. So this is part of the reason why we want to remove the close association between different parts of the app. That way when you change one thing, it doesn't have to be constantly updated everywhere. However, we can't test out our new insert employee method because we didn't do that functionality yet on our app. Now, rather than go through all the steps of creating a user interface where we can type in all of our employee things, we've done it before where we had a user interface to type in all the department things. So I don't feel like that needs to be repeated in this video. What I'm going to do instead is just create a button, and I'll just drop it right in here. And this button is going to generate an employee and try to insert that employee into the database. So I created this button. I'm going to make it say test add employee. And I'm going to put it into that little spot right in this part of the grid. So it is column 0 or column 1, row 1. I want to remove this row span so that it doesn't take up that other space as well. And I'm going to make it line up with that other button here. So I'm going to change vertical alignment to center. There we go. So let's create a click event on this button. We need to give it a name, btn add emp. We'll make a click event for it. And we're going to generate a new employee object. And insert the new employee into the database. Okay, so when we generated a new department object, let's just take a look at that code for a minute. We generated a new department by getting all of the values from the text boxes. I'm going to do the same sort of thing, except I'm not going to retrieve values from text boxes. I'm just going to hard code some values. We're just using this for testing. You know, if I was going to production on this, obviously I would create a form where you can type in your name and whatnot. So I'm going to create a new employee object, new employee, and we're going to set all these values. I'll just pause while I type. So I've used our object initializer, need to fix my quotes, to generate values for all of these. You know, you can get these values from anywhere, but I've just hard-coded them just to save us some time. Notice I did not assign a value to emp ID. That's something that's assigned by the database table. It's an identity column. I can't specify what the employee ID is going to be. So my next step then is to insert this new employee into the database. And remember when we call that insert method that it's going to return to us. Oh, my Visual Studio just crashed. I'll pause my video while I solve that problem. Okay, so when we call that insert method to insert the new employee, we pass the employee object and it passes it back. But before passing it back, it sets the value of emp ID for us. So I'm going to call on insert employee to insert this new employee object, and it's going to send back the new value for that employee. So we're going to send it, and it sends it back. In order to verify that this worked, I'm just going to use a message dialog to pop up and tell us what this new employee's ID is. So we'll have a message dialog, and we're going to have content that says employee. We'll put the name in here as ID, and we'll put the employee ID in here. So just a quick little verification message. The emp first is part of the employee object, and so is the emp ID. Here we go, and we will show this message dialog. So we can click the button, generate this employee, insert them into the database, and update our reference so that our employee object reference here has that new ID. That part's actually not required, but that is the common practice when calling these Dapper methods. Obviously, the object reference is a reference type, so you wouldn't need to perform that assignment in order to be able to get it, but that's the general accepted practice, is to send it and return it. Okay, so let's try it out. Okay, so when I click on Test Add Employee, we get employee Samantha, that's the first name that I entered, has ID of 10. Well, let's take a look at our database. This is the current list of employees that was there last time I ran a select statement. You can see we already had employee 9. If I select the list of employees now, my new employee has been inserted and is inserted as number 10. Now, I'm going to close this and click the button again. You can see that it inserted the same information, but it generated another new ID. So if we come back here, we can make sure that we can take a look and verify that all the data is getting inserted properly, and you can see that it's just the same data over and over, but it is generating unique identities. Okay, so let's move on. We're going to look at creating an ordered list procedure, which is what I call the stored procedure for returning a list of lookup values. The purpose of this is to populate a combo box. So we have situations a lot of time when we're working with data that's stored in relational databases where you only have, you have this referential integrity relationship where it's limited the values that you can choose to insert into a child record. So what I mean by that is if we're going to insert a new employee, we have to provide a department code, but the only valid department codes are those found in the department table. So from a user interface perspective, we don't want to provide just a text box where the user can type whatever department code they want, because if you try to enter a department code that isn't found in the department table, we know that that causes an error in our database. You can't do that. So to make it easier for the user, if we had a form that allowed them to enter in their new employee data, type the first name, type the last name, we might consider using a combo box or something similar, like a list of radio buttons or whatever, if it's a short list. You want to consider something that can restrict their entry so that instead of having to type and know the department code, they can choose from a list of departments, and maybe it shows the names or it shows some kind of information. And when they choose that, it allows them, it allows us rather to enforce a finite list of choices. So we want to create a stored procedure that can produce that list. Now, the thing about our current app, if I go back to it for a minute, is that this app already retrieves a list of departments because we use it to populate the list view. So retrieving the list of departments in a different way might not be the most advantageous choice. You're maintaining two separate lists from the same table. That's not always great. Consider, though, that if we wanted to really make a form that adds employees, what we probably would do would be to create another page, or at the very least, another layer on this page that deals with that employee insert form. And you don't need every bit of information from the department. All you need is the department code so that they can select the value, and the department name or some kind of summary showing you what the department is so that you can look at which one you're choosing. So it's a nice way for us to restrict the amount of data imported when we don't need all of the extra information. Now, for this particular app, I'm going to put a combo box right into this area so that I can create a list of valid department codes. And then when we click on our adding employee, I'm going to modify the code a little bit so that instead of putting them into marketing every time, I'm going to get the selected value from that combo box. So it's just a little part of the overarching idea that we want to be able to restrict and control how users can enter things when there is a list of restrictions. So let's give our combo box a name, CBO select department or something similar to that. There we go. And make it a little bit wider. This thing is in row 1. We want to make sure that it's in column 0. And we have center vertical alignment. Okay, so our combo box now is all set, and it's ready to be filled up with a list of departments. Now again, we want to create, this is the vessel where the list of departments is going to go. In the code behind, oops, I pressed the wrong button and executed. Hang on one second. Here we go. In the code behind, we want to fill up that combo box when the page loads. Now, I already have a method that reloads all of the data. So we can use this method, or we could put it up here in the constructor so that it only happens once. It's a good idea to put it in this load data because if the department values change, we always called this method after. So after inserting or updating or deleting departments, this method always gets called to get the updated list so we can update the drop-down box as well. So our goal here is to populate the combo box with a list of departments. So it's going to be very similar to the way that we populated the list view with a list of departments. The difference is that the combo box doesn't operate with so much outputs. There's only really two things that a combo box can show. There's what we call the display member, which is what you actually see when you look at the combo box. And then there's also behind it what we call the value, or, for the one that's selected, is called the selected value, which is actually the object that is being chosen. So we have two things, the value that's being selected and the display that shows you what that value is. They're not always the same. For example, for us, we want to be able to select things like this that are 4-letter department codes. But we don't want the user to see the department codes. We want them to be able to see things like accounting so that they can pick the name of the department that they want. Or if we want to go farther, we can give more information about it. For example, if we wanted to display the budget of that department, or if you have other records, or if you wanted to display like the room number of that department, you can create whatever kind of summary you want to display. And then typically it's the key value that acts as the actual value of the combo box. So we're going to represent that with an object called key value pair. Now I know we've touched briefly on key value pair before, but essentially a key value pair is a type of an object that has two properties. One is called key, one is called value. When we learn about collections in our C# class, key value pair is the type of object that's stored inside a dictionary collection. So you have the key, and you have the value. And we're going to use key value pairs to represent the elements inside the combo box. The key being the department code, and then the value being the name or the summary of the department information. In order to retrieve this from the database, we're creating a stored procedure that can create a list of keys and values. My select statement selects the primary key, and we call that key. The aliases are important here. And then for the value, I'm producing a summary or a description of departments. So in this case, we're going to see the department name and the department budget formatted as currency, and that's going to be the value. It's also really important when you're creating an ordered list procedure that it's actually ordered by something. You want to control the order, because if you have a combo box and the user is trying to find a particular value in a combo box, that's really difficult to do if the items aren't in order. So it's very important to order your ordered list procedure. It's right in the name. Okay, so let's create this ordered list procedure in our database. I'm just going to pause while I type it. Here we go. So we'll execute that to create the procedure, and now I'm going to execute the procedure so that we can see the outcome. So we have two columns, key and value. The keys are going to be the things that are selected by the combo box, and the values are going to be the things that are displayed by the combo box. So by creating a procedure that returns these two specific columns, key with a capital K and value with a capital V, it allows us to map it to the key value pair object. The same way that creating a select statement, let's scroll back up here. Our select statement allowed those three properties to match to our department object in C#. The properties have the same names, gets put into a department object. Here, the properties are going to have the same names, key and value, so we can put it into a key value pair object. So in our app, we're going to move away from populating the combo box, because first we have to make the method that calls that procedure. So I'm going to create another method in my code library that allows us to return that list of key value pairs. Now, we have other methods that return lists of other things, so let's go and use one of those as a template. Here's the one that returns a list of all department objects. So I'm going to copy this. But instead of creating a list of departments, I'm going to create a list of key value pairs. Now, when you create a key value pair, you'll notice that there's a generic and a non-generic one. We want to use the one that allows us to specify data types. So we would use something like this, where the key is a string and the value is a string. And this is the type of object that we're creating. So we allow this generic one. But we're not just returning one key value pair. We're returning a whole collection of key value pairs. In this case, there's 4 of them. So when we return the list, we're returning a list not of department objects, but of key value pair objects. So returning a list of key value pairs, and each key value pair has a string key and a string value. So we need to rename this method, obviously. So we'll give it a name like list departments. Instead of getting all departments, which is getting everything from the department table, we would execute the stored procedure. And we modify our query to specify that our command type is going to change to stored procedure. That's the same way that we've done before. But instead of a list of departments, we're having a list of string-string key value pairs. So I'm replacing department with key value pairs of string and string. So those are the only changes that we need to make. We execute the procedure. It's going to return to us a list of key value pairs. Each key value pair object has a string for the key and a string for the value. So just as a little minor demonstration, if we wanted to look at each key value pair, we can say for each key value pair object in our list, you can see how KV, oops, I forgot to, we forgot to specify this. Now KV has a key property and it has a value property. So that's how we execute the 2 parts, or how we access rather the 2 parts of a key value pair. Now another option is you could create another object class to represent an element in a combo box that has whatever 2 named properties you want. But since key value pair is already built in, I figured we might as well just make use of that. So now we have a method that we can call that gives us the list of key value pairs that we can call from our database. And we can use this as the source of our combo box. So it's the same 2 steps. To start, we're going to take our combo box and change its items source to that list of key value pairs. But if we were to run it now, you would see that our combo box would show us that there are 4 elements, but it wouldn't show what the 4 elements are because it doesn't understand how to map this object to the combo box. Now remember I said earlier that the combo boxes basically have two things that it can do. It can have a value in the code behind, and it can have a display member. So we want to write some settings to indicate how the combo box should assign its value and how it should assign the thing that it's displaying. So let's do the displaying one first because we can test it and actually see it. Our combo box display member path. So this is what the combo box shows. What part of the key value pair do we want to show? Well, let's take a look at it in our database again. Which one is the one we want to show? That's the value property. So we put in the name of the property that we want to show. Now, which one do we want to use as the selected? So when you pick option whatever, what's the actual value that you're going to get? And the actual value that you want is the key property. And I put it in the slides that when we write the method and then when we call the method, the naming is counterintuitive because the selected value of the combo box is actually the key property. So, don't mix up which value is what. It is a little bit counterintuitive, but I can't really get around that because the key value pair, the key is actually, the primary key that we want. And when you select it, the combo box calls it selected value. So we just have to put a little flag on that and note it because we can't change it. So our combo box selected value path is going to be the key property. So now we can assign that list of elements. I think I named these things a little differently than what's in the slides. The last thing that I'm going to do is set one of these to be selected. So I'm going to pre-select the first one in the list so that the combo box does not appear as empty on the screen. That's just a nice little user interface tweak so that the combo box actually has chosen something by default. All right, so let's run it and we'll test out all of those working parts. Okay, so our combo box doesn't necessarily fit, but you can see how it is populated. The display members are the values generated from our stored procedure. But when I choose it, I'm going to modify my test add employee button so that it can show us which one we've chosen. And because I've set selected value path, it's going to show us the key from the key value pair. Let's go back into our button click event handler. So when we try to add a new employee, instead of getting a hard-coded department code, I can get it from the selected value of the combo box. Now the underline is because it doesn't recognize it as a string, but we know that that value is going to be a string. Oh, I don't need a semicolon there. Now, before this happens, I'm just going to comment out this code for a minute because I want to do some testing. I'm going to use the message dialog. Oops. That will show us the selected value. So we can make sure that our combo box selected value is being captured correctly. So here's my app. I'm going to choose marketing. And when I click the button, you can see that the selected value is the department code that I need. And if I choose a different one, then I get the correct department code. So now that we have verified that it's correct, I'm going to comment my test. And we will uncomment the code that actually works. So we've got the selected value being assigned as department code. And this is a nice way to provide the list of valid options to the user. They can pick a department code rather than having to guess or type or whatever. So we'll test this out one last time to make sure that we can insert employees with different departments. I'm going to start off by displaying all the employees that we currently have. And I'm going to just move this over here. So I'm going to choose the Information Systems department and try to add an employee to that. And we'll make sure that it works. So our new employee works in Information Systems. If I choose a different department, I have another new employee who works in Personnel. Okay, so that wraps up this video. We talked about how to call stored procedures to decouple our SQL statements from our data library. And we also talked about some additional stored procedure that we can use to populate the combo box. Now, in the next video, we're going to do another additional stored procedure that allows us to return a filtered list of elements based on some user input on the interface where they can control and enter some filtering criteria. Until then, I will see you next time.